exercise 6. It has 3 parts. This is part A. Let us first solve this and then we will see the other parts. So in part A, what is given is that a man has $4.55 or $4.55 in change composed entirely of dimes and quarters. What are the minimum and maximum numbers of coins that he can have? And also, is it possible for the number of dimes to equal the number of quarters? So, we are going to consider two variables. One is the number of dimes and the other is the number of quarters. So, let's start the solution here. Let the man have X dimes and Y quarters. Now, if we convert everything into cents, then 10 cents is 1 dime and 25 cents is 1 quarter. So, we have this Diophantine equation. 10x plus 25y equal to 455. Because the man will have 10x cents coming from the x number of dimes and 25y cents coming from the from y quarters. So this is the total number of cents he has. And if you convert this also into cents, then you get 455 cents. So you get this Diophantine equation, which is equivalent to the equation. You can see that you can divide on both sides by 5. All the coefficients include, and this constant term, they are all divisible by 5. So you have 2x plus 5y equal to 91. So you get this Diophantine equation. Now, from theory, we can write the general solution to this equation. The general solution to the above Diophantine equation is this. I have it here with me. You can go to that theorem that we are using here to write the general solution and see that you are getting this itself. So the solution is this: x equal to minus 182 minus 5t and y equal to 91 plus 2t, where t of course is an arbitrary integer. But because this is the number of dimes and this is the number of number of quarters, they must be positive, right? And this must be non-negative actually. So for non-negative solutions we must have these inequalities. That is, this must be non-negative and this also must be non-negative. Minus 182 minus 5t must be non-negative and 91 plus 2t must also be non-negative. These inequalities give us these following conditions on t: minus 45.5 less than or equal to t, and t is less than or equal to minus 36.4. You can see that if you add 5t on both sides of the first inequality, you get minus 182 greater than or equal to 5t. You can then divide on both sides of that inequality by 5. So minus 182 divided by 5 should be greater than or equal to t, and that is minus 36.4. Similarly, from this one you get t greater than or equal to minus 91 divided by 2, and that thing is this. So that's how you have a range for t. But now you know that t is an integer, so from this you will have some values of t. Thus, the possible values of t are minus 30. Keep in mind it has to be less than or equal to, in fact we need not bother about the equality. These inequalities also have the possibility of equality in them, but that we will never have because these are non-integer, these are fractions, right? These are non-integer rational numbers, whereas t is an integer. So t must be strictly less than minus 36.4. So one such value is minus 37, then there are others of course. Minus 38, minus 39, minus 40, minus 41, minus 42, minus 43, minus 44, and also minus 45, but not minus 46, because minus 46 is not greater than or equal to minus 45.5, it is less than this. So these are the possible values of t, and corresponding to these values we have these solutions. The corresponding solutions are these. So this you just have to put these t values here and here and find the x and y values. So any such pair of x and y values that gives you a solution. For example, if you put t equal to minus 37, then you are going to get x equal to 3 and y equal to 17. Then if you put minus 38, you are going to get x equal to 8 and y equal to 15. Because these are numerical values, you know what I want you to do. You verify that these things are actually correct numerically. Then in the next one, you have both x and y equal to 13. Then x is 18, y is 11. Then how many have we found? 1, 2, 3, 4. 2, 3, 4. So we have some more. Then x is 23, y is 9. Next, x is 28, y is 7. And we have others as well. All of these things that we are writing are solutions, okay? Which means that if you go back to the original equation from where we started the calculation and put these x and y values, that equation is going to be satisfied for each such pair. Then next, after 28 and 7, we have 33 and 5. Then 38 and 3. And finally 43 and 1. I am not going to verify these things here, of course, but I want you to do that. But at least we can see how many solutions we have got and match that with the number of p-values here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And this last one corresponds to t equal to minus 45. But recall that in the exercise we have been asked about the maximum and minimum number of coins. We have x dimes and y quarters, so the total number of coins is x plus y. That number should be we have to find the solutions where that number is maximum and where that number is minimum. Now the minimum is given by this first solution where x is 3 and y is 17. So x plus y is 20, and the maximum is given by the last one. The minimum number of coins the man has is to show where this is coming from, we are writing 3 plus 17. And the maximum number of coins is again x plus y, but here x is 43 and y is 1. So you can, the bank can have $4.55 by having any combination of these number of times and number of quarters. But among them, when he has 3 dimes and 17 quarters, then also he has $4.55, but the number of coins is the least. Whereas when he has 43 dimes and only 1 quarter, he has the maximum number of coins, which is 44. And you can understand that also because 10 dimes give you 10 cents give you 1 dime, whereas 25 cents give you 1 quarter. So if you have more quarters, then you have less number of coins. If you have more dimes, then you have more number of coins, naturally. So that's why this gives you the minimum number of coins, whereas this gives you the maximum number of coins. And one more thing was asked, is it possible for the number of dimes to equal the number of quarters? Yes, such a possibility also we have seen. It has cropped up here. When the I cannot write it this way. The number of dimes can equal the number of quarters when both of them are equal to 30. Can equal the number of quarters when they are both 13. So the man can have 13 quarters and 13 dimes. Then also he has $4.55. So that is part A. Now let us see part B. The part B is this. A neighborhood theater charges $1.80 for adult admissions adult admissions. I forgot admission spelling. How nice. And $0.75, that is 75 cents for children. Okay, on a particular evening, the receipts were how much? $90. Assuming that more adults than children were present, more adults than children were present, how many people attended? So there is some theater in a neighborhood that charges $1.80 for an adult admission and 75 cents for children. On a particular evening, I think I did not write total, no? The total receipts were $90. And also it is given that on that particular evening there were more adults than children. Then how many people attended the theater on that evening? So because we are doing the solution in this fragmented form, so again let us write solution but for part B. Let x, I have to see what I have written here, x adults and y children, because otherwise I won't know what the solution is. Yes, let x adults and y children attended the theater on that evening. So adult admission it costs $1.80, that means 180 cents. Then, so if x adults were there, then 180x cents were accumulated, plus 75 cents for one child. So y number of children were present there, so 75 y cents additionally, and the total receipts were $90, that means 9,000 cents. Now of course you can simplify this, which is equivalent to, it turns out that all these numbers are divisible by 15, and when you do that the equation reduces to this, what did I just say now, 15. Is it really, let me just see, okay, I think I have already made a mistake, I think. I have maybe I have mixed things up. Okay, that's a very bad thing. Shall I have the answer that is the answer here? Because it should be 600, no? Anyway, let me just write the equation, finally what we will get. This is equivalent to this. Okay. What I have here is I have written 90 here, but this of course is not 90. In order for this to be 90 here, we have to divide by 100, not 15. I hope this is just simply a matter of writing the wrong number there and not the solution that comes after this. The general solution to the above Diophantine equation is x equal to minus 1200 plus 5t and y is equal to 3000 minus 12t, where t is an integer. Now the point is this: if I put this value here and this value here, am I going to get 600? If so, then this equation is correct. Let me just take some time to do that. Think about that. If I put the x value here, then 12 times 5t, and if I put the y value here, then 5 times 12t with a minus sign, they cancel each other, fine. But at the same time, 12 times this, that is going to give me what? 144, and then we have 2 zeros, and this times this, that means 15, because 5 times 3000 is 15,000, but with a plus sign. Now if you do the calculation, then what will you get? Yes, we are getting 600, fine. That was just simply a matter of writing the wrong number. Okay, now there is no problem. The solution is correct. Now we can write the rest of it. Okay. Now it was also given in the statement of the exercise that more adults attended than children. So this is the number of adults, this is the number of children. This should be greater than or equal to this, and both of them should be non-negative because they represent numbers of objects, numbers of people actually. For non-negative solutions and also in order to satisfy the hypothesis. Actually there is no need to write this much, but for the sake of clarity I am writing. You know what hypothesis? That there are more adults than children. So because of all these things, we should now have these following inequalities. This should be, see, more adults than children. So you cannot put the equality possibility here. It is strictly greater than 3000 minus 12t. which is greater than or equal to 0. Maybe it's the case that no child attended. That may also be the case. This, however, cannot be 0 because it's given that this is strictly greater than the number of children. And now these inequalities give us what? The above inequalities give us these following things, these following inequalities. 247.05 is strictly less than t, and t is less than or equal to 250. You can understand that this inequality is coming from here and this one is coming from here. So the possible t values are going to be what? It should be greater than 247, in fact 0.05. So the t values will start from 248, t can be 249 and t can be 250, and that's just it. 3 possible values. The corresponding solutions for these t values are the following: x equal to 40 and y is equal to 24. Then when t is 249, x is 45 and y is 12. And finally, when t is 250, then x is 50 and y is 0. So you see that this possibility has actually arisen, that if no child attended on that evening and only adults attended, 50 adults attended. Okay, so that gave rise to that 9,000 figure, 9,000 cents. So these are all the possibilities. Now from among these possibilities, which one is true, that we cannot decide. In order to determine that, we need more information, but these are all the possibilities. Okay, now there is this part C also. So that's the solution to part B. Part C is this: a certain number of 6s and 9s are added to give a sum of 126. Something else is also given: if the number of 6s and 9s are interchanged, if they are swapped, numbers of 6s and 9s are interchanged, then the new sum is $114. How many of each were there originally? Okay, so as usual, let us proceed by first considering two variables. Let x6s and y9s together give us 126. So you know what we are considering here. Then first of all, just expressing this in the form of an equation, we get 6x plus 9y equal to 126. But if these two numbers are swapped, now say you have x here and y there, then that new sum is 114. So 9x plus 6y is 114. So now it's a matter of just solving these two equations, and it turns out that the solution, that is both the x value and the y value, are actually integers, and that solution is this. Solving these equations, we get, I think one of the numbers is 10. Yeah, x is 6 and y is 10. Just to see that I have not messed up the order, if you take x equal to 6 here, then you get 56 plus 60. So that gives us what? Am I getting it wrong? Oh, this is not 56, this is 54. 411, 140, yes, okay. So this finally completes the solution to exercise 6. Next, let us see 7. These are almost like the problems that we normally encounter in school, but the difference is that here the variables are supposed to have integer values. That's why these are not ordinary equations, these are Diophantine equations, and that's why the theory of Diophantine equations has to be applied to solve this. Okay, anyway, now let's see exercise 7. In 7 we have a farmer made a purchase of 100 head of livestock. Number of livestock animals of some form were purchased for a total cost of $4,000. That's a lot of money. prices were as follows. So calves were bought for how much? $120 each. Then lambs, $50 each, and some piglets too. For $25 each, baby pigs. If the farmer obtained one animal of each type, okay, one animal of each type. One animal of each. Oh, by that the author means that the farmer obtained at least one animal of each type. That's what he means. Then we have to find the numbers, right? How many of each did he buy? So three types of things are involved here. So we have to consider three variables, but we are going to also have two equations. So we can use those two equations to eliminate one variable, and then whatever equation we end up with, which will have two variables, on that we are going to apply the theory of Diophantine equation, solve that, and then from that we can get the value of the variable that we eliminated. Okay, so the solution of course starts like this. Let the let C calves, L lambs, and P piglets were obtained. So this type of names given to the variables help us know which one is what easily. C for calves, L for lambs, and P for piglets. Then in total he had 100 items. So C plus L plus P is 100. That is one equation. But then we look at the prices. $120 for calves. So 120C plus 50 for lambs, 50L, and 25 for piglets. P equal to $4,000. Here, because everything is in dollars, so we do not need to convert the unit. The second equation is equivalent to, so it will assume a simple form. So what you have to do, you are going to divide by 25. is total division possible by 25 if we do, we then end up with this equation 24. Something doesn't look right here also, no? It's not 25, I think. It is 5, okay. Still something is not right. This won't be 19, this will be 24. That means I have messed up here. Let me write and then see if it's correct or not. 10L plus 5P is equal to 800. So what we have done here is that we have divided by 5. Yeah, if we divide by 5, this naturally would be 24, not 19. That's what I have written there, which is wrong. And then of course 10 and 5 and 800. Yeah, now it's okay. Okay, now we use this equation and this equation to get rid of P. Okay, that's what we have done here. Using these two equations, we get 19c plus 5. Oh, this is where we also have 19, and this is where we actually have 19. 19c plus 5l is equal to 300. But here also, instead of just suspecting if something is wrong, let me actually see. So what we have done is that in place of P, we have written 100 minus C minus L. So what goes on when you write that here in place of P? 100 minus C minus L. Let me quickly see. And that should be equal to 800. So when you multiply these two out, you get 500. You take that 500 on that side, it becomes minus 500. Actually, I should not say like that, but that's how we can figure things out. 800 minus 500 is 300. Fine. So the right hand side is fine. But what goes on here itself? 24c minus 5c is 19c. And 10l minus 5l is 5. Yes, correct. So that means there is no problem with this one. So now what we do, now we write the general solution to this Diophantine equation. To the above Diophantine equation, is this: C equal to minus 300 plus 5t, and L is equal to 1200 minus 19t. Okay, for positive solutions. Note carefully that we are not writing here non-negative solutions. That's not what we are writing. We are straight away writing positive solutions. Why? Because it is mentioned in the exercise that one animal of each type has actually been purchased. So none of the variables will have zero value. Each one of them will have some positive value. So for positivity of the number of calves and number of lambs, we should have this and also this. These inequalities give us what? Ultimately it gives us 60 less than t less than 63. The possible values of t are thus 61 and 60, only two values. Oh, 60, oh sorry, see, I did not even, in my haste, I forgot that this one is not an integer, it is 63.157. So there will be three possible values. (61, 62 and 63). So 63 will also be there, and the corresponding solutions are, okay, now when we write the solutions, we will not just simply write the C and L values, but simultaneously the corresponding P values as well, which will come from the C and L values using this equation, for example. So you find the C and L values for t equal to 61, say, then you add them up and subtract that number from 100, that gives you P value. So these are the solutions that we get for these corresponding T values. C equal to 5 calves, 41 lambs and 54 piglets. That is one possibility, and then there are other two. And these solutions will satisfy both the equations. That is, if you take the sum total of these numbers, you should get 100 in all these three cases, and also that second equation where the prices are involved, that should also be satisfied. And then after this we have C equal to 10, L equal to 22 and P equal to 68. 10, 22 and 68, and one more, C equal to 15 calves, only 3 lambs and 82 piglets. So these are all the possible solutions, and you can see that in each one of them we have all the animal types. And let's see one more. This one is somewhat interesting for in a strange manner. When Mr. Smith not interesting for the name but for the actual problem itself. Cashed a check at his bank the teller mistook the number of cents the number of cents for the number of dollars and vice versa. What a mistake, but it can happen, of course. Unaware of this, so he gets the cash and he spends 68 cents from it. Unaware of this, Mr. Smith spent $0.68 and then noticed to his surprise that he still has more money than what was written on the check. Actually, it should have been less money, but he finds that even after spending 68 cents, he still has more money than what was written on the check. How much more? In fact, twice that amount. To his surprise, where is it? That he had twice the amount of the original check. Determine the smallest value for which the check could have been written. And there is hint also given which actually gives away the solution itself. If X denotes the number of dollars and Y the number of cents, if X denotes the number of dollars and Y the number of cents written on the check, in the check, then 100 by plus X minus 68 is equal to 2 times 100x plus Y. But why? That's because if Mr. Smith actually wrote X dollars and Y cents, then he should have, what is the total number of cents? X dollars means 100 X cents plus Y cents already also has been written. So the total number of cents that the check has written on it is this. This should have been written by the tailor himself. But the tailor switched these two things, messed this up, and thus paid Mr. Smith this many cents, 100 by plus X, which Mr. Smith took with him, and from that he spent 68, and then he saw that strangely he still has more money than what he intended to withdraw. In fact, twice the actual amount. Okay, so that's why this equation is arising. Now we have to solve this equation. Following the given hint, we of course have this equation, and following the given hint also means that we already know what X and Y are. Okay, so no need to again write what they are. 100X plus Y. Which is, so you can do simplification, and this becomes equivalent to this equation, which is 98Y minus 199X is equal to 68. The general solution to this Diophantine equation is X equal to minus 2244 plus 98T. And keep in mind that these are things you have to actually verify on your own and see that whatever I am writing is actually something correct and not simply nonsense. And the Y value is minus 4556 plus 199T, where T is any arbitrary integer. T is coming from the set of all integers. For positive solutions, we must of course have minus 2244 plus 98T greater than 0, and also that one greater than 0. Now here we are not going to get any bounded region for T, because both the inequalities are similar in nature. Both of them have positive coefficients for T. It's not the case that one of them has a positive coefficient and the other one has a negative coefficient. Had that been the case, we would have got say two inequalities between two numbers T had to lie, but that's not the case here. So both of them are going to give us the same type of inequality, and in fact actually they give us the same inequality, and that inequality is this. But before that, let me, I did not write this. Plus 199t must be greater than 0. We are considering greater than 0 and not greater than or equal to 0. That is because it turns out that when you divide this by this or this by this, you do not get an integer, you get a fraction. So you can just consider greater than 0. Both these inequalities give us t greater than or equal to 23. Actually, they give us t greater than or equal to 22 point something. Maybe this that number or those numbers that you get from this one and from this one are actually different, but both of them are 22 point something. Since t is an integer, so that reduces to this possibility. Now, if t is actually greater than or equal to 24, the fact that we already have this inequality, this one means assuming that t is not 23 but the other possible values, then the y value using this inequality, it turns out that the y value is itself greater than or equal to 200, what was the value? 220. But y was what? Y was the number of cents, the actual number of cents that was written by Mr. Smith on the check. Since the number of cents is a 2-digit integer. Why? Because if it exceeds 2 digits, then you take out $1 or how many dollars there are in that number of cents and add that with the number of dollars, and the leftover then becomes the number of cents. So that is why, since it has to be a 2-digit integer, whereas when t is at least 24, this becomes greater than or equal to 220. So in that case, it cannot be a 2-digit integer. We thus must have t equal to 23, and in this case x should be what? 10 and y is 21. $10.21, a check for $10.21. Okay, for the sake of mathematics, it's okay. So now let me just end the video here itself, because I believe it has been quite long. There is one more exercise number 9 in this set of exercises. Once we finish that, this section and this chapter is, both of them are over. Now that 9th one has quite a few subdivisions, so I am not doing it here today. Otherwise I would have finished it. So we will see that in the next number theory update. And our next upload is this coming Friday, and this Friday let us go back to graph theory, where hopefully we will complete this section, that is the ongoing section about the interaction between graph theory and linear algebra. So see you on Friday with that. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.